Topic is Faraday's law, Lenz's law, and inductance. Faraday's law. Before going to Faraday's law, we will learn about two experiments. First one is this figure shows that a conducting loop connected to a sensitive ammeter because there is no battery or other sources of EMF induced included. There is no current in the circuit. However, if move a bar magnet toward the loop, a current suddenly appears in the circuit. The current disappears when magnet stops. If we then move magnet away, a current again suddenly appears, but now in opposite direction. In this experiment, current appears only if there is a relative motion between the loop and the magnet. The current disappears when the relative motion between them ceases. Faster the motion produces a greater current. Second experiment. For this experiment, we use two conducting loops close to each other but not touching. If we switch on is to turn on a current in the right-handed loop, the ammeter suddenly and briefly registers a current. Nothing but induced current in the left-hand loop. If we switch off the loop, right-hand loop, another sudden and brief induced current appears in the left-hand loop, but in opposite direction. We get an induced current only when the current in the right-hand loop is changing, and not current when it is constant. The current produced in the loop is called an induced current. The work done per unit charge to produce that current to move the conduction electrons that constitute the current is called an induced EMF, and the process of producing the current and EMF is called the induction. The current produced in the loop is called an induced current. The work done per unit charge to produce is called an induced EMF, and the process of producing the current and EMF is called the induction. Faraday's law of induction. Faraday's law states that a changing magnetic flux induces an EMF and electromotive force. Electromotive force epsilon is equal to minus d pi b by dt. This is for this equation for one loop. Epsilon equal to minus n d pi b by dt. This is equation for n loops. So the induced EMF in a wire loop is proportional to the rate of change of magnetic flux through the loop. What is magnetic flux? The magnetic flux is proportional to the number of magnetic flux lines passing through the area. Units of magnetic flux is Weber. 1 Weber is equal to 1 Tesla meter square. This is equal to electric flux in electrostatics. What is EMF? Electromotive force. Mathematically can be written as epsilon is equal to closed integral EDL. Looks like a potential. It's a driving force for a current. Lenz's law. The minus sign gives the direction of induced EMF. The induced EMF is in direction that opposes the change in flux that causes it. So we have seen in these figures magnetic field direction and current direction are perpendicular to each other. Here I am showing some examples of Lenz's law. In A, the magnetic field in A figure, the magnetic field and flux are increasing. The current moves in the direction to oppose that to decrease the magnetic field. In figure B, the magnetic field and flux are decreasing. Again, the current moves in the direction to oppose that. In figure C, there is no change in flux, so there is no induced EMF. What is in this slide? I am also showing Faraday's law in integral form. Closed integral EDL equal to minus integral dou v by dou t dot dA. In differential form, del cross E equal to minus dou v by dou t. The minus sign gives the direction of induced EMF. That is comes from Lenz's law. So I already shown these figures about Lenz's law. What is inductance? There are two types of inductance: mutual inductance and self-inductance. Suppose you have two loops of wire at rest, as shown in figure A. If you run a steady current I1 around loop 1, it gives an magnetic field B1. Some of the field lines pass through the loop 2. Let pi 2 be the flux of B1 through 2. By applying Biot-Savart's law, B1 is equal to mu naught I1 by 4 pi integral dl1 cross r cap by r square. Here dl1 is length segment of loop 1. dl2 is length segment of loop 2. Reveals one significant fact that about this field, it is proportional to current, means that here flux in loop 2 is proportional to current I1. So pi 2 is equal to M21 I1. Here M21 is the constant of proportionality. It is known as mutual inductance of the two loops. There is a cute formula for mutual inductance which you can derive by expressing the flux in terms of vector potential and applying Stokes theorem. Pi 2 is equal to integral b1 dA2 equal to integral del cross a1 dot dA2 equal to closed integral a1 dl2. a1 equal to mu naught I1 by 4 pi closed integral dl1 by r, and hence pi 2 equal to mu naught I1 by 4 pi closed integral into closed integral dl1 by r dot dl2. This gives mutual inductance M21 mu naught by 4 pi double closed integral dl1 dot dl2 by r. This is the Newman formula. It involves a double line integral, one integration around loop 1 and other around loop 2. It is not very useful for practical calculations, but it does reveal two important things about mutual inductance. M21 is a purely geometrical quantity having to do with the sizes, shapes and relative positions of two loops. An integral in equation M21 is unchanged if switch the roles of loop 1 and 2. It follows that M21 is equal to M12. This is an astonishing conclusion. Whatever the shapes and position of the loops, the flux through 2 when we run a current I around loop 1 is identical to the flux through the loop 1 when we send the same current I around loop 2. So here we may as well drop the subscripts and call them both M. By now by applying Faraday law, the changing flux epsilon 2 is equal to minus d pi 2 by dt, that is equal to minus m di1 by dt. A changing current not only induces an EMF in any nearby loops, it also induces an EMF in the source loop itself. Once again, the field is proportional to the current. The magnetic flux is proportional to current. Pi is equal to Li. Here L is constant of proportionality. Is called self-inductance. If the current changes, the EMF induced in the loop is epsilon equal to minus L di by dt. Here we are taking inductance in henries. 1 Henry is a Henry is a volt second per ampere. So what is self inductance? Self inductance is that it induces an EMF in the same source itself, called self inductance. So the EMF is given by Faraday law, epsilon equal to minus L dI by dt. Thank you on and all. So in this topic I covered Faraday's law, Lenz's law and inductance.